this is Mrs. Davis. I wanted to do a video on combining like terms, a video of my own. Yesterday there was an interruption with my internet connection, so I had to do this the way that I did. So I hope you were able to understand combining like terms with the Chuck Norris example. And then it did actually replace Chuck Norris with a variable, but I'll just explain from here so you get a better visual. So what are like terms? Like terms are terms that have the same variable with the same exponents. So it kind of still mentioned terms, and you probably are still wondering, like, okay, now what are terms? So I will simplify it. Terms are any number, so it could be a numerical term, which is like 1 through to a million. It's a number, okay? And then it can also be a coefficient with a variable behind it. So like the 5x is a term, 3y is a term. It's what is being computed in the algebraic expression. So it could be whatever number, and then you have to imagine there's an exponent even when you don't see one. So if you have 5x, the exponent is imaginary. It's 1. Okay, the exponent is 1. Just like if there's no number in front of x, you have to imagine that there's a number 1 there, not a 0. There is a number 1. Okay, so 5x, 3y, and 2x. Let me put a marker here. You know which one I'm talking about. This one here. 5x, 3y, and 2x are the terms. Okay, so you have the algebraic expressions here. You have your terms here. You have the like terms here. The like terms are terms that have the same variable and the same exponent. So 5x and 2x have the same variable, x, and the same exponent, 1. 3y would be a separate term. Okay, so 5x and 2x are your like terms. In the algebraic expression, 8z to the second power plus 4z plus 12z to the second power, you have the terms 8z to the second power, 4z, and 12z to the second power. But what are the like terms? So remember, the terms have to have the same exponent. Okay, you see this, it has the same variable z, but it doesn't have this, they all do not have the same exponent. 8z to the second power and 4z are not the same, but 8z to the second power and 12z to the second power are like terms because they have the same variable and the same exponent too. Okay, so next, 15 minus 3x plus 5. 15 and 5 are the like terms. 3x is a term, but it is not the same as 15 and 5. So if you were to simplify this expression, you would have 20, because 15 plus 5 is 20, minus 3x. Okay, now I'm going to go down here to, one second. Now that I want to move the screen, I can't. Okay. Okay, let's see. I can move it up slightly. It says baseball caps cost $9 and patches cost $4. Shipping is $8 per order. The expression 9n plus 4n plus 8 gives the cost in dollars of buying caps with patches for n players. So it's n is a variable for the unknown amount of players. 9 is the cost of the baseball caps. 4 is the cost of the patches. So this algebraic expression would give us the amount of money it would cost for however many amount of players to buy caps with patches. And then you have to know that by this here problem that $8 is what you're paying for shipping. Sorry. So 9N plus 4N plus $8 for shipping. So it asks you to simplify the expression 9N plus 4N plus 8. To simplify the expression, you would combine your like terms, which in this case would be, now I moved it. Okay, great. 1 second. So your like terms in this expression would be 9N and 4N. So 9N plus 4N would be, let's see, 9N plus 4N. So you are basically just adding. So 9 plus 4 is 13. And then you would put your N behind it. 9N plus 4N is 13N. And then you would put plus 8. You can't forget the 8. So that's the $8 for shipping. So any amount of players you can put here. So say for instance it's 2 players, then that's 13 times 2 plus 8. 13 times 2 would be 26. 26 plus 8 would be 34. So in that case, if you have 2 players, then you're paying $34 for buying baseball caps and patches, plus your $8 for shipping. So I hope you were able to understand that. I will be giving more examples so that you would have all the help you need for the problems you need to compute for combining like terms. Okay, so I wanted to go over the last problem I did on the recorder screen. So this is simplifying an expression. 9N plus 4N plus 8. To simplify this expression, you just combine the like terms and you leave it as that. I'm not asking you to solve it, it's only to simplify it. So to show you know how to combine the like terms. 9N plus 4N, 9 plus 4 is 13. So you would have 13N plus 8. And then to get more of a visual, I'll do one of these. This is how the book shows you. So you would separate all of your N's. So let's do 9 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this would be, this is 9N because each one is an N. So this is what 9N looks like if it had a look. So each individual one, combining it together, that's 1, 2, 3, 4, 5, 6, 7, 8, 9 N's. So that even helps you to understand that if you have one N, then that's what it is. It's one N, but you just don't place the 1 in front of it. You just know that N by itself is one N. That's like if you had a basket, you put this in it, you have one N in that basket. Okay, so 9N plus 4N. So 1, 2, 3, 4. 1, 2, 3, 4. This here is 4N. So the 9, so then to check your answer, 9, you know 9 and 4 is 13. But if you wanted to know how many ends do I have, you just count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 13 ends. So that's how you combine your like terms. So if you wanted a visual, there's your visual, 13 in, and then you bring down the plus 8. There's no like term to the numerical term number 8. So you would just leave it like this. This is the simplified version of 9n plus 4n plus 8. Okay, so I'm going to do another problem. It says that paintbrushes normally cost $5 each. So paintbrushes, okay, they cost $5 each, but they are on sale for $1 off. So $1 off minus $1, so they're now $4. Okay, a paintbrush case costs $12. The expression, so let me back up, paintbrush case costs $12. The expression says 5p minus p plus 12, 5p minus p plus 12 can be used to find the cost in dollars of buying P paintbrushes on sale plus a case for them. So minus P because one, okay, so P are the paintbrushes. So paintbrushes normally cost $5 each, but they're on sale for $1 off. I mean, I think that you really don't need to put the minus P. You could just do 4P because we already established that 5 minus 1, which was the dollar, that it's off $5. I'm sorry, dollar off of the 5 is $4. So it would be 4p plus 12. But I see what they're doing. They want you to combine like terms. If you combine the like terms, then 5p minus p would equal 4p. So now you have 4p plus 12. Now it says simplify the expression by combining the like terms. So I've already done that. So to simplify 5p minus p plus 12, that would be 5p take away p, which is 4p, and then you bring down the plus 12. So this would be your simplified expression. So I'll do one more. And this one won't be a word problem, so I'll just set it up this way. 6x plus 2x to the second power minus 4x. Okay, now combine the like terms. So the terms are 6x, 2x to the second power, and 4x. But the like terms are only 6x and 4x. So 6x, and you can't say plus 4x because there's a minus in front of the 4x. So you would do 6x minus 4x. And then bring down plus 2x to the second power. Now 6x minus 4x is the same as saying 6 take away 4, which is 2. So you will have 2x plus 2x to the second power. So remember, the variable have to have the same exponent. X to the first power, or x to the power of 1 is what we imagine. And then 2x to the second power, they're not the same. So you would leave it as this, 2x plus 2x to the second power. Okay, so we're going to do one more. 3 plus 2x minus 1 plus 8x. First, we have to figure out which terms are alike. So this is a number, this is a number. It doesn't have a variable, so those are your like terms. This is 2x, it has a variable x. This is 8x, it has a variable x, and there's no, they have the same exponent. The imaginary exponent is 1. So let's combine first the 3 and the 1. So since there's a minus in front of the 1, you would do 3 minus 1. 3 minus 1 equals 2. So then we would do bring down our 2. And then 2x plus 8x is 10x. So 2 plus 10x would be your simplified expression. Do one more just so I make sure that we get this. 5x squared plus 2x to the third power plus 4x squared. The terms are 5x squared, 2x to the third power, 4x squared, or 4x to the second power. The 2 is second power. Okay, so you need to group them. Which ones are the like terms? They have to have the same variable and same exponent. X, 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 but you have 2, 3, 2. So you would combine the ones with the x to the second power. 5 plus 4 is 9. So 9x to the second power. And then you would bring down plus 2x to the third power. This is your simplified expression. Okay, and I keep saying one more, but I just want to make sure that we get this. So one more. Let's do 4 plus 9 plus 10x minus 3x. The like terms, well, first the terms are 4, 9, 10x, and 3x. The like terms are 4 and 9 and 10x and 3x. So 4 plus 9 is 13. Bring down our plus. 10x minus 3x, it's the same as saying 10 minus 3. 10 minus 3 is 7. So you would put 7x. Okay, don't forget your variable. So 13 plus 7x is your simplified expression. So you don't need to solve it. I just want you to simplify it. Okay, the curriculum, Go Math, wants you to simplify it. Okay, so that is simplifying an expression by combining the like terms. Okay, and that is going to be it. I hope everyone's having a great day, staying safe. Make sure you wash your hands, don't touch your face, and stay indoors whenever you can. All right, have a great day.